The area to be visited in this trip lies between Taparo Point and Angler Point. This 50,000 scale Kugler surface geology map shows the distribution of the mud flows, upper and lower cruise formation. The lower cruise is mapped as clay pebble beds. The main problem with its location is that we would expect these outcrops to be located along the crest of the southern anticline. Its position, therefore, is anomalous. They probably represent disturbed sediments with boulders within mudflow. The pink dots are the outcrop localities, and we can clearly see that some of these localities are significantly inland of the 1959 coastline, suggesting significant coastal erosion. This structural cross-section through the Booth area has been interpreted that the mud is rising upwards along the reverse fault to the surface. The cruise and the lengua formations were proposed as the source of the mud. However, abundant Chert and Herrera class suggest a Herrera source. The topographic map shows the outcrops that were visited. Two of the outcrop localities are well offshore and represent the advance of the 2018 slump that dramatically changed the coastline. At the first outcrop, we see blue-gray clay and mudflow. At top 2, we have a large block of grayish-orange sand surrounded by mudflow. Within this mudflow, we find a block of coarse Herrera
sandstone.
At outcrop number 3, we see a large block of north-dipping sandstone, which is fairly massive except for the middle.
Along the surface.
It has been mapped as lower cruise and Kugler, however it's probably just a block floating within mud. In this panoramic view of Taparo Point, we see Los Zero B on the left and Paliseco B on the right.
Los Zero B. So here we have a significantly larger block of sandstone which appears to be floating within the clay.
In this drone video shot from 200 feet,
here we see a large cast of offshore what appears to be conglomeratic type Herrera. Here we see a big block of in-place, what appears to be in-place north-dipping sandstone here at Taparo Point. There is a huge block of sandstone within the sea, and with it we can see some big rounded boulders partially weathering out of the surface. In the background we're seeing Venezuela, and most of these ships we're seeing in the background there are ore carriers in which this ore is being transshipped in smaller vessels that come down the Orinoco.
Dominated by
here we see some extremely deformed mud
flow in these sands and sand clays.
In it,
fossil gastropods.
You can see remnants of
modern land
layered
gastropods.
stones and thin sands.
At stop number 5, we see old slumped mudflows that have uplifted an old beach on top of its toe. This beach was apparently later buried by sandy clay stones. In this close-up of the
you can see that there is significant slumping
there is
of this mud
bivalve
shells
and trachyclasts. Here we have a photograph of bivalve shells recovered from the raised beach sediments. One we clearly recognize as chip-chip, or Donax as its scientific name. At stop number 6, we see deformed sand and claystone beds within the mudflow.
Here we have an area of horizontal beds. So obviously these have to be fairly recent in origin and probably represent part of the old beach that was uplifted.
Thanks for watching this video.
So here we see fairly recent gastropod within it, which can probably be used to date these rocks. Here we have what appears to be an old uplifted beach, uplifted by slumping of the mud flow onto the beach and uplifting the rocks. So we see abundant chert, we see Herrera class, we see what clearly appear to be northern range metamorphics, which of course are unusual. We see banded chert, here we are seeing extensive slumping of material. Here we are seeing the remnants of sand and claystone beds being deformed within these slumped deposits. Here we have a large block of Herrera looking sandstone, and we see that the base of it is a very coarse sandstone tending almost to conglomerate, and we see the upper unit It's a very fine parallel laminated sand. So we are actually seeing what appears to be a Bauma sequence within this particular sand outcrop.
This Herrera block shows TA and TB units of a Bauma sequence. In this panoramic view of the tour of the 21st August 2018 post-earthquake Los Cerros slump, piles of boulders mark the limit of the advance of this failure. The current coastline is still seaward of the pre-earthquake coastline.
We are now at the base of the slump at Los Cerros that was generated by the 2018 earthquake. These boulders here would have marked the original position in 2018. We see that the coastline has retreated about 20 feet. And we see that this material is typical mudflow. It's been homogenized. And we see these very small, well-rounded clasts within the material itself. Here we have what appears to be a bit of a calcite vein floating within the mud. Above us, we are seeing the former shoreline that was uplifted by a rotational block at the toe of this slide. We see some fairly large rounded boulders here. We're now on top of this rotational block. We see no sand. We see the remnants of boulders which were formerly on the shoreline. We see that the inland part of this feature is lower, which confirms that we're looking at a rotational slump block at the toe of this slide.
In this cartoon, we illustrate how a rotational slump and its compressional toe has created the uplifted beach and the scarp at the front of the slump on the current coastline.
We have now rounded Taparo Point and we're passing the 2018 slump, and we're now walking east along Paloseco Bay. First headland is Angler Point, and the second headland in distance, that is Roja Point near Quinam.
This drone photo taken on the 30th of August 2018 shows the original toe of the failure and extensive raised beach. These comparative pre- and post-2018 earthquake Google Earth images show the changes in the shoreline as a result of the slump. This photo shows that there has been significant erosion and collapse of the slump on its eastern side. There are areas on the beach where there has been some new uplift near the cliff base due to continued ground movement. At some undetermined future time, the area inland will collapse seaward once more.